A highly gifted child claims that Cern scientists opened the gateway to another dimension in 2022. Since then, we have been on a different timeline, and no one except a few geniuses like Laughlin are said to have noticed. Are the tests in the Large Hadron Collider really destroying our reality, and are the scientists conjuring up a disaster of enormous proportions with their experiments? Follow us on this journey into a science that crosses borders into a completely new view of our reality discovery. A dimensional gate has opened. On July 7, 2022, at 5:18 a.m., a shocking discovery was made. A mysterious crack appeared in the Earth's magnetic field. The crack appeared out of nowhere and remained open for a full 14 hours. The anomaly allowed solar winds to flow into the Earth's magnetic field, causing strong geomagnetic disturbances and possibly much more. How did this crack suddenly appear, and what does it have to do with the tests at the Large Hadron Collider in Geneva? Researchers were quick to come up with an explanation, claiming that the crack in the Earth's magnetic field was due to a unique phenomenon called the corrotating interaction region, CIR. CIR is a phenomenon in solar physics that results from the interaction of different solar wind streams. The solar wind consists of charged particles emitted from the sun into space. These particle streams never move uniformly in all directions but have different velocities and densities. Near the sun, sometimes several of these solar wind streams meet and overlap, forming very large plasmatic formations that exert a special effect on the Earth's magnetic field. Unlike normal plasma streams, they can apparently tear a real hole in the Earth's magnetic field. CIRs have not yet been researched sufficiently to be able to say what consequences this really leads to. Interestingly, 3 new exotic particles were discovered in the Geneva Collider at exactly this time, including a new type of Peter quark and the first pair of tetrax, which include a completely new tetracore. Scientists claim that the Large Hadron Collider deep underground is absolutely safe and does not interact in any way with the outside world. But can this be true? After all, we are moving here in the subatomic realm, exactly where matter becomes nothing more than oscillation and rotation with gigantic empty spaces between tiny particles. Quantum mechanics have long pointed out that the building blocks of our matter are multidimensional, that particles of light are in multiple places at once and even transcend the barriers of time and space. So how can researchers claim that none of the particles being researched at the controversial Cern facility are getting outside or interacting with other dimensions of the universe? Officially, 70 new hadrons were discovered by the Cern community during the series of tests. These are subatomic particles composed of quarks and held together by the elementary force of the strong nuclear force. However, critics of the facility claim that Cern is doing far more experimentation in depth than is officially known, and that is what could put us all at risk. There have been frequent speculations that the organization is trying to create black holes, unwittingly or deliberately opening gates to other dimensions we cannot control. Warning! Warning from an extraordinary child. Max Laughlin is a highly gifted boy who, out of nowhere, has extensive knowledge of quantum physics and the nature of our reality. He warned in a video that Cern had destroyed the old universe when it resumed operation of the facility in April 2022. He claimed that there had been an original timeline, but because of the experiment, an anomaly had immediately occurred, catapulting us into an infinite number of parallel universes. According to quantum physics, however, there would be nothing too unusual about this, because if experiments like Schrödinger's cat and Wigner's friend are right, we are all constantly moving through a multitude of universes with our decisions and measurements of consciousness. Max Laughlin, however, believes that the experiments have shifted humanity as a collective, along with the planet, into another dimension. Most of us have been unaware of this. Let's hope this new level of reality is a good one. No black holes. No black holes, no dangerous experiments. A physics professor from the University of Buffalo involved in the testing explained that the collider or any technology for that matter can't access black holes at this time, because there are still certain limitations. However, it's known that minor breakdowns in the spacetime continuum have occurred in Geneva that are similar in nature to black holes. When this became known, it led to protests against Cern, with a group of people demanding that the particle accelerator be shut down. Again and again, strange weather phenomena occur around Geneva, and local residents report perceptions that cannot be explained by normal means. Several professors and renowned researchers have also spoken out and reaffirmed their confidence in the Large Hadron Collider. The main goal of this current run of tests at the particle accelerator is to find out more about a mysterious fifth force of nature that researchers believe exists. This fifth force, if found, would completely change the dynamics of particle physics. Only no one has really seen or measured it yet. Critics of the facility are up in arms about it. Again, they claim that the researchers are playing God in the depths of the Earth, and that no one can really foresee the true consequences of these experiments at the moment. Large Hadron Collider. The Large Hadron Collider, LHC, for short, is the largest and most energetic particle accelerator in the world. It took 2 decades to build, accompanied by protests and criticism. While more than 10,000 international scientists, hundreds of universities and institutions, and 100 countries were working on this revolutionary project, ordinary people in the Swiss city of Geneva feared for their peace and safety. Despite petitions and complaints, the Swiss government and international funders pushed ahead with the construction of the more than €7.5 billion facility. The particle accelerator is located between 100 and 175 meters below the Earth's surface. Above it are residential areas, supermarkets, kindergartens, and roads. Those who don't know about the existence of the facility imagine they are in a completely normal city. But the people of Geneva are increasingly unable to forget what is going on there in the depths. The actual facility is the 27-kilometer-long tunnel in the form of a ring, consisting of superconducting magnets, special acceleration structures massively increasing the energy of particles. 2 beams of particles travel clockwise and counterclockwise, respectively, at a speed close to the speed of light. The particles collide. Only through this ultra-fast collision do the particles become measurable. They interact with each other or decay into still smaller particles. The main components of protons are quarks and gluons. Quarks, being subatomic particles, are very unstable and usually decay in a fraction of a second, while gluons are the mediating force. The entire collision is detected by detectors inside the accelerator, and the data are sent to a network of computer systems. From the decay and behavior of the particles during the collisions, researchers hope to learn more about particles far below the limit of what is visible. No human has ever seen even a photon or an electron in isolation with their own eyes. Researchers only know of the existence of these particles because they can observe their effects and behavior. The first collision in the Large Hadron Collider was performed 2 years after the accelerator was completed in 2010. Prior to that, similar tests were conducted at a predecessor facility, but the prototype particle research facility was far less energy charged. The tests from 2010 took place at a combined energy of 7 tera-electron volts, which was nearly 4 times higher than any previous and comparable test series. But that still wasn't enough to produce ever smaller particles. Further upgrades increased the intensity of the combined energy to 13 tera-electron volts to produce. In 2018, the plant was unexpectedly shut down. Local residents linked the plant's shutdown to a strange weather phenomenon that had appeared over Geneva during the summer. In addition, people in Switzerland and neighboring regions in southern Germany and France reported strange events, and seismologists measured many smaller earthquakes. But all of this is officially said to have nothing whatsoever to do with the shutdown of the facility. For 2 years, the LHC remained off. Then, in 2021, the first test runs went through again, this time with a maximum beam energy of 6.8 tera-electron volts per beam. The new full test series is expected to last until 2025. Higgs boson, the God particle. Over the years, the Large Hadron Collider has solved some big mysteries, such as the Higgs boson particle. Before the collision in 2012, the Higgs boson particle and the Higgs field were only a theory, as researchers could not detect it even after numerous experiments. After further upgrades to the collider, the Higgs boson was finally detected. In the course of this series of tests, the researchers also searched for more information about dark matter and so-called ghost particles or neutrinos, which are similar to electrons but carry no electric charge and are created in the depths of stars. The Higgs mechanism is a theoretical concept that explains how particles acquire their mass. The Higgs field permeates all of space and imparts mass to other elementary particles as they move through the web. Without the Higgs field, most particles, including quarks and electrons, would have no mass and continue to travel through space at the speed of light without taking on a solid form. The field is thus instrumental in the formation of matter and thus a basic structure of the universe. The discovery of the Higgs boson was announced in 2012 and was a great success for particle physics. At that time, there was more frequent talk in the media of the God particle. Far stranger than the God particle are strangelets, hypothetical exotic matter objects made of strange quarks. Strange quarks are one of the 6 directions of quarks, the fundamental building blocks of hadrons, which also include protons and neutrons. Unlike the light up and down quarks that make up ordinary matter, strange quarks are heavier and more unstable. The idea behind strangelets is that they could represent a collection of strange quarks in a stable state. They could form when enough energy is applied to create strange quarks and keep them in a larger system before they decay. Strangelets could also form as a result of a collision of extremely high-energy particles. One of the special properties of strangelets is their stability compared to normal matter. It's speculated that once a strangelet forms, it could act as a catalyst for the transformation of ordinary matter into strange matter. This has led to scientific discussions about whether strangelets could be a potential hazard if they were created in our environment. Experts claim that a strangelet escaping to freedom from the experimental facilities in Geneva could threaten the stability of the entire universe. So, the criticisms are more than justified, for strangelets are so-called, not least because they are strange or unpredictable. Who knows which path such a particle could take to escape? But Cern remains unimpressed. They are currently planning to further improve the collision energy and the detectors that record the behavior of the particles.